Welcome to Dasanti Discoveries, where today we venture into the deepest, darkest realms of the universe. Black holes, these mysterious, massive objects defy our understanding of physics and captivate our imagination. From their formation to their unimaginable power, black holes are among the most fascinating and enigmatic phenomena in the cosmos. But what exactly are they? How do they form? And what lies within these cosmic giants? Join us as we unravel the mysteries of black holes. Black holes are regions in space where gravity is so strong that nothing, not even light, can escape their pull. The idea of a black hole first emerged in the 18th century, when scientists began to contemplate the existence of objects with such strong gravity that they could trap light. However, it wasn't until Albert Einstein developed his theory of general relativity in 1915 that the concept of black holes became grounded in the framework of physics. Einstein's theory showed that gravity is not just a force between masses, but rather a curvature of spacetime itself. Massive objects like stars cause spacetime to curve, and this curvature is what we perceive as gravity. The more massive an object, the greater its curvature of spacetime, and in the case of black holes, this curvature becomes so extreme that it creates a point of no return, the event horizon. So, how do black holes form? The most common way is through the death of a massive star. When a star exhausts its nuclear fuel, it can no longer support itself against the force of gravity. If the star is massive enough, typically more than 20 times the mass of our Sun, it will undergo a supernova explosion, shedding its outer layers. The core that remains collapses under its own gravity, and if it is dense enough, it will form a black hole. But not all black holes are born from dying stars. There are other types, each with its own unique origin story. Stellar black holes, like the ones we just described, are the most common. However, there are also supermassive black holes, which reside at the centers of galaxies, including our own Milky Way. These behemoths can be millions or even billions of times the mass of the Sun. How they form is still a topic of intense research, but they may grow by merging with other black holes and by accumulating vast amounts of gas and stars. Another type is the intermediate mass black hole, which is larger than stellar black holes but smaller than supermassive ones. These are much rarer and harder to find, but their existence suggests a possible link between the formation of stellar and supermassive black holes. One of the most intriguing aspects of black holes is the event horizon, the boundary beyond which nothing can escape. The event horizon is not a physical surface, but rather an imaginary boundary. Once something crosses it, there is no turning back. It is the ultimate point of no return, where the gravitational pull becomes so intense that escape velocity exceeds the speed of light. Inside the event horizon lies the singularity, the very heart of a black hole. The singularity is a point where the curvature of spacetime becomes infinite, and the laws of physics as we know them break down. In this region, densities are infinite, and all matter is crushed to a point of zero volume. This is where our understanding of the universe reaches its limits. The singularity is a place where quantum mechanics and general relativity collide, and a unified theory of quantum gravity is needed to fully comprehend what happens inside. As we approach a black hole, something extraordinary happens. Time itself begins to slow down. This effect, known as time dilation, is a consequence of the extreme gravitational pull near a black hole. From the perspective of an outside observer, time appears to move slower and slower as an object approaches the event horizon. In fact, if you were to watch someone fall into a black hole, you would see them gradually slow down and freeze at the event horizon, never actually crossing it. But for the person falling into the black hole, the experience is quite different. They would continue to fall, experiencing what is perhaps the most dramatic effect of all spaghettification. This term describes the process by which objects are stretched and elongated as they approach the black hole. The intense gravitational forces exert a stronger pull on the part of the object closer to the black hole, causing it to stretch into a long, thin shape, much like spaghetti. For a long time, black holes were thought to be entirely black, with no way for anything to escape their grasp. But in 1974, the renowned physicist Stephen Hawking proposed a groundbreaking idea. Black holes could actually emit radiation, now known as Hawking radiation. This discovery was revolutionary because it suggested that black holes are not completely black. After all, they can slowly lose mass and eventually evaporate. Hawking radiation arises from quantum effects near the event horizon. According to quantum theory, empty space is not truly empty. It is filled with virtual particle pairs that spontaneously pop into and out of existence. Normally, these particles annihilate each other almost instantly, but near the event horizon, one of these particles can be captured by the black hole, while the other escapes into space as radiation. Over time, this process causes the black hole to lose mass, and in theory, could lead to its eventual evaporation. Black holes are not just destructive forces, they also play a crucial role in shaping the universe. For instance, supermassive black holes at the centers of galaxies are believed to influence the formation and evolution of galaxies themselves. The gravitational pull of these black holes can affect the motion of stars and gas within the galaxy, and they can even regulate star formation by expelling or heating the gas needed to create new stars. In some cases, black holes can also give birth to some of the most energetic phenomena in the universe. When matter falls into a black hole, it can form an accretion disk, a swirling mass of gas, dust, and other material that spirals inward. The friction and gravitational forces within the accretion disk generate immense heat and radiation, which can be observed as X-rays or gamma rays. In certain situations, black holes can also produce powerful jets of particles that shoot out at nearly the speed of light, extending far beyond the host galaxy. Our understanding of black holes has advanced significantly over the past few decades, but there is still much we do not know. One of the most exciting developments in recent years is the first ever image of a black hole, captured by the Event Horizon Telescope in 2019. This groundbreaking achievement provided direct visual evidence of a black hole's event horizon and opened up new avenues for research. Looking ahead, scientists hope to uncover even more about black holes, particularly in the realms of quantum mechanics and general relativity. Questions remain about the nature of singularities, the potential for wormholes or other exotic structures, and the ultimate fate of black holes as they lose mass through Hawking radiation. There is also the tantalizing possibility of detecting gravitational waves ripples in spacetime caused by the merging of black holes or other massive objects. The detection of these waves has already provided new insights into the behavior of black holes and the fundamental nature of gravity. Black holes remain one of the most mysterious and captivating phenomena in the universe. Their formation, their immense power, and the mind-bending physics that govern them challenge our understanding of reality itself. As we continue to explore these cosmic enigmas, we not only learn more about the universe, but also push the boundaries of human knowledge and imagination. Thank you for joining us on this journey into the science of black holes. If you enjoyed this video, please like, subscribe, and hit the notification bell to stay updated with our latest explorations of the cosmos. The universe is vast and full of mysteries, and together we can continue to discover its wonders.